Hello everyone, this is Chris back again with the Ancient Scholar. Today I'm going to talk about something a little different. I know I've kind of torn away from the hemodynamics. I haven't forgotten hemodynamics, and I'm just preparing to do a couple of videos on that. Again, that's going to be a little more involved because I'll be talking about the pulmonary artery catheter, which just by its very nature is a bit more complicated and a little more involved. But I wanted to go ahead and throw out some new material on some concepts that I know really confused me when I had to take chemistry, and I imagine it probably confuses other people. And that is on this concept known as an isomer, or isomers. And I think if we just spend a little bit of time talking about this, we can at least get a better intuitive understanding, and then it doesn't become, or it's not as scary. So let's just talk about what an isomer is. Isomer, literally, when we talk about the terminology of it, it literally means equal plus part, or equal parts. So that should tell us something. And that is really the fundamental logic behind isomers, is that we are talking about a molecule, or a substance, a molecule actually, and it has the same molecular formula but a different structure. So let's try to make some sense of what I just said there. So it has the same molecular formula, but a different structure. And instead of talking about atoms, let's make it a little bit more intuitive, and let's pretend that we're playing with some Legos. And I don't really have some Legos, that's too bad. But let's just go ahead and pretend that I have a red Lego. Or you know what, I have two red Legos. I've got a little blue Lego and some three flat green Legos. Okay, so what I have here, I have a bunch of Legos. And this would be analogous to the molecular formula. Just like H2O is a molecular formula, but that doesn't tell us anything about the structure, does it? H2O, that doesn't tell us anything about the structure. It just tells us that's what we have atom-wise. One molecule of water is going to have two hydrogens and one oxygen, but it doesn't necessarily tell us anything about the structure. Well, that's the same thing here. I have two red Legos, a blue, and three green. Now, how I arrange these guys may or may not take on different forms. Maybe I have them arranged like this. Maybe I decide to arrange them like this. So you can see the arrangement is different. The structure is different here. But the molecular formula, the same stuff, the two reds, the blue, and the three greens, the same stuff is still there, it's just arranged differently. And that is exactly what I mean by an isomer. So going back to just to seal the logic, so molecular formula for water would be something like this, but when we talk about the structure of water, we know that it takes on sort of a structure like this, with the hydrogens taking on partial positives and the oxygen taking on a partial negative. So that's the actual structure of water versus the molecular formula. And that is the entire logic behind isomers. Okay, so hopefully we have a logical understanding that we're talking about something that has the same number of atoms, but those atoms can be arranged differently. So then what we need to do is we need to realize there are different types of isomers. And I'm not actually going to get into them today, but we will get there. And the two general types of isomers either fall into one of two categories. Something known as a structural or constitutional isomer, or my second category, which is actually very important, very, very important of a lot of different things, and this category is known as the stereoisomers. Or sometimes we call these spatial isomers. So these are the two broad categories, and then of course we have subcategories within these. So hopefully everybody has at least an intuitive understanding of what I mean when I say isomer, and then we'll go ahead and start classifying the different types of isomers in subsequent videos. Okay guys, have a great day. Thanks for hanging in there.